This is, I think, the fourth in a series of webinars we've been doing. And the purpose of this presentation is to provide you with a better understanding of how the Datapaq Food Tracker system can be used when measuring cooking and baking processes. Now, the food processing industry has a very, very wide range of processes, cooking in different mediums, for example, submersion in oil or in air. So today's webinar has to be fairly general in the information I will share. But if you need any more detailed information, then please feel free to email myself or contact your local sales manager for more detail. As Leonardo said, scheduled to last half an hour. I'm going to start by covering some of the hardware components of the system, and then into the second half of the webinar, I've got 6 or 7 slides detailing how some of the software features can be used in optimizing food cooking process. Before we start all that, a 3-slide, very brief introduction to Datapaq and where we fit within Fluke and our global footprint. So Datapaq has been designing and building profiling systems since 1984. It's all we do. We're specialists in that area. The company was founded in Cambridge in the United Kingdom, and the hardware, so the mechanical, the electronic and software design is still based here in Cambridge, along with product marketing and order management for both Europe and Asia. In 2007, I believe, Datapaq was acquired by what was the Danaher Corporation, and we operate as part of Fluke. And you can see the Fluke logo over on the left-hand side of this slide, which shows the Fortive organization, which spun out of Danaher. And you can see some very familiar brands fall within the Fortive organization, and there's over 24,000 employees globally in this organization. If we drill down a little bit into Fluke Process Instruments, it comprises 3 brands. So Raytec, Ercon, and Datapaq came together. All 3 companies are specialists in temperature measurement. In particular, Raytec and Ercon are non-contact, so using infrared, either pyrometry, spot pyrometry, line scanners, or thermal imaging cameras. And over on the right-hand side is Datapaq with the contact measurement based on temperature profiling systems. Our global footprint, as I said, we research development based here in Cambridge in the UK. Manufacturing of all the data loggers and components is undertaken at our facility in Berlin in Germany, where we also have a service center covering Europe. We have sales and service centers in Shanghai and in Everett in the USA, which is up in Washington State, which is also the Fluke Corporation headquarters. Sales offices for Datapaq products in particular are in Salem, USA, Mumbai in India, and in Singapore, where Andrew is based. You saw him on the first slide. Datapaq divides the world's thermal processing industry into different segments. The one we're interested today is food processing. As I said earlier, the applications within food processing are fairly diverse compared to other industries. For example, in the electronics, we're always just heating things up in air and going to less than 300 degrees. In food, we have these different considerations of steam injection, oil cooking, and air cooking. In my experience, the profilers are used to improve product quality and to reduce the time taken when setting up cookers or processes and to increase yields. They're predominantly used in cook chill, so ready meals, baking, pastries and breads, and meat and poultry cooking, where the lethality calculations and chill down times are very important in maintaining food safety. All of the ovens in which the profiling systems are used have controlled thermocouples measuring air temperature and possibly humidity in the heated zones, but that really doesn't give the full picture. Because of the variability in the product going in, the variability in the food product, using a profiler is really the best and many times the only way of measuring the core temperature of the product as it gets through the process. And this is particularly useful when you're looking to validate processes and working within the HACCP protocols. Okay, that gets the general introduction, if you like, completed. And if we drill down in a little bit more detail on the data logger, this is the heart of the food tracker system. And the Multipaq21 data logger was designed specifically for this process. We didn't repurpose one of the data loggers that we use in the other industries. This was designed from day one to be used in the food industry. It's unique amongst our products in that it operates from -40 centigrade all the way through to 85 without any thermal protection at those temperatures. And the calibration is guaranteed over that range. It's fully sealed to IP67, and that includes the battery compartment. So there's a sealed nickel metal hydride rechargeable battery within this unit. A typical user life for that's going to be 3 years. And it will have to come back to the service centres at the end of that time when the battery needs replacing. Thermocouple connectors are designed by us specifically for use with this data logger in the food industry. They provide a fully sealed connection. A standard thermocouple connector, as you know, is open to the elements. It will work 1 or 2 times going through a food process, but within time, the sockets get filled with grease and contaminants, which affects the readings. So we've gone for a fully sealed version here. The connectors have O-rings on them to maintain the sealing. They also have a keyway to ensure that they're inserted correctly, just to protect those pins, which are, can be vulnerable. They're quite small, so do take care when plugging those in. To maintain the sealing of this system, if there are thermocouple channels you're not using, unlikely on a 6-channel logger, but maybe on the 8-channel there's 1 or 2 you're not using, then insert blanking plugs or some old thermocouple plugs into those holes just to maintain the sealing. The unit is available with a radio frequency telemetry module as called out on the slide there, and I'll talk about that later, and also a humidity sensor, which isn't shown on here, which is also available. Moving on from the data logger, 2 or 3 slides now just on thermocouples. The task in the food industry is a little more of a challenge when it comes to sensors than in some of the other industries we serve. If you imagine the luxury of connecting a thermocouple to a piece of metal is that you can bolt it on, screw it on, weld it on, make a really good connection to the product on either the surface or the core temperatures, and it's very easy. Compare that to food processing, where we have a variation in product size, product consistency from almost fluid through to meat logs. We have food that's already packaged at the time that you want to measure it. That's the 2 thermocouples in the middle of this slide were specifically designed around use in packaged food. So the challenge here is selecting the right thermocouple for the process. All of them are type T. This is the standard for the food industry. And all of the thermocouples that we sell conform to the special limits of error, which for a type T thermocouple is plus or minus 0.5 degree C, or 0.4% of the reading. So all the way up to sterilization temperatures, around 120, 125 degrees, your accuracy is going to be the plus or minus 0.5. From as you go above that, the 0.4% of reading becomes more dominant. And in terms of selecting thermocouples, the major point here is to ensure that the thermocouple is robust enough that it survives the process, but small enough that it's not making changes to what you want to measure. And I'll come into more detail on that on the next slide. So here's a close-up on some of the thermocouples you just saw. If I start in the top left, this is a mineral insulated, is what the MI stands for in this case, a mineral insulated needle probe. Used extensively. It has a unique feature among the thermocouples on this page in that it can be used at temperatures from all the way up to 400 centigrade, type T thermocouple. All of the others are limited to 265 by the PTFE used on the insulation. So this is our high temperature food thermocouple. The downside of that is it's less flexible. It's a steel outer or metal outer sheath with the thermocouple wires embedded within it. So it finds application generally high temperature, large food items used in baking of pizzas, bread baking, that sort of application. Next down, we come to what we call the standard needle probe. I guess it's fairly obvious what this one does. It's for inserting into food products. The advice I give here is to ensure that this is used in products where most of the needle, if not all of it, can be inserted into the product. If you were to use this in a very small product, such as a chicken nugget, and you have a substantial portion of the thermocouple outside of the product, you're going to get what we call stem conduction. The thermocouple itself becomes heated. It will conduct that energy along the thermocouple into the product. What you measure then is a mixture of the conduction along the thermocouple and the product temperature, which is not what you want. So really match the size of the thermocouple to the product being measured. So that brings us on to the next one, which is the short needle. I think it needs very little explanation. It's used in similar products, but of a smaller size. So small portions, small needle. As you can see, it's got a barb on it to prevent it pulling out. Top right, heavy duty, or what we would call heavy duty for this industry. That's typically used in large products such as ham and ham curing. Again, you would want to ensure that it's inserted right up to the T-bar, just to ensure you're not getting conduction down the thermocouple affecting your readings. The air thermocouple, that looks a lot like the thermocouples we use in other industries. It's really only useful here in conjunction with some kind of a frame or a jig that goes across a conveyorized process. And this is really for use in surveying ovens and checking uniformity from left to right across a conveyor process. So I would have a bar mounted across the width of the oven with these thermocouples clipped on at regular intervals to measure my air temperature across the process. And finally, the food probe. It's just a PTFE type T thermocouple cable with a very small, very sensitive tip on the end of it. Very little mechanical strength, so we can't insert this into solid products. This is used in products that are sort of semi-solid or liquid state. And bread proving would be a good example of a low temperature process where we could insert this into measure a core temperature. The humidity sensor I talked about very briefly when I introduced the data logger. This is an option and allows you to measure relative humidity through the process and display it as a third axis on the time and temperature graphs. So we have a time, temperature, humidity graph. And this really is beneficial. And I've seen it used a number of times to control the steam injection in a process, improving moisture retention and increasing product yields. Most of these ovens or processes where we have humidity control will have 1 or 2 sensors maximum. And it really doesn't give you an indication of what's happening where in the process. Having that measurement of relative humidity from start to finish really does enable you to optimize the process with no risk. It's also used in the baking industry in the control of crust formation with the moisture condensing on the product. A couple of important points to remember if you're going to use the humidity sensor. As it says on the slide here, it's limited to 200 degrees, so we wouldn't want to use it in temperatures above that. It has a capacitive sensor in the tip, and that will be damaged at use beyond 200 degrees. And in some applications where we're going to go from a reasonably controlled, dry environment in the factory floor and put this into a warm, humid oven, we could get condensation on the sensor. And in those applications, we would advise preheating it prior to putting it into the process. And we can provide more information and even a preheating unit for use with this thermocouple. The lower image, I just thought I would mention it. We've got probe tags, really useful when you've got a large rack with lots of products on it and you're going to be placing 6, 8 thermocouples. Typically, you will have put the data logger in the thermal barrier, closed it up. That's the easiest way to carry it over to the process. You place it in the rack. You're then left with this mass of thermocouples to place, and you haven't labeled the ends or the tips. These are simple metal tags that can clip onto the thermocouple wires, alleviate the problem. Also available is an organizer to actually hold the plugs together in order for clipping onto the data logger itself. So all of the food barriers can accommodate that. Fits on the front of the data logger. So with the tags at one end and all the thermocouple plugs organized at the other end, it should ensure repeatability of results and having the thermocouples in the same place every time you use the system. That's enough on the thermocouples. Moving on to the thermal barriers. There's a wide range in the food industry, as I said right up front. The food industry or food processing industry has a very wide range of processes. And we've designed the barriers to meet the needs of the key processes. And the ones you see here on the screen, you can see at least 3 of them feature some kind of fitting or compression fitting or a gland that goes around the thermocouple wire to seal the barrier from the outside process. This isn't to protect the data logger, it's to protect the insulation within the barriers from steam, moisture, oils, greases that are in the process. The thermal barrier range varies from 40 millimeters high, which will provide protection for 40 minutes at 200 degrees, up to something around 100 millimeters high, where I could get 240 minutes protection at 200 degrees. And that huge increase in thermal protection capacity with just a doubling of the height is down to the fact that we can put heat sinks that absorb the heat energy into those larger barriers, whereas the smaller ones rely solely on the microporous ceramic materials. This photo only shows a small range of the barriers available. Our design team here in Cambridge is always willing to meet challenges, and so if you have a process and you don't think there's something suitable from our current range, please get in contact with your local sales manager. We're always open to challenges and designing bespoke solutions for processes. There's a couple of accessories here I wanted to point out just to make life a little bit easier. Processing, profiling in food processes is quite tricky in that if you imagine the case at the top here in this first picture, I have a thermal barrier. I'm going to connect 6 thermocouples to small food portions and place them across the width of my conveyor. To walk up to a moving conveyor with a thermal barrier in one hand and those 6 or 7 products in the other hand is very difficult. No doubt some of them will fall off the end of the thermocouples before you get there. So we would advise the use of a tray, like the one you see here, where the thermal barrier, thermocouples are held in place. The food portions can just be placed directly on the end of the thermocouples, and then you've only got one item to place onto the moving belt. So it's a very simple operation. You make a gap in the current production, drop the system on in minutes and send it through the oven. That way you're measuring the fully loaded oven, which is the aim of all of these profiling systems, to measure what's going on in a fully loaded oven. That can work on narrow belts. What you see in the lower picture is what we would do for a wider conveyor where it's not possible to have a single basket that covers the width of a 2-meter wide conveyor. For that, we would offer a simple adjustable width bar onto which the thermocouples can be mounted, and you place the bar on the belt, and following just behind it is the barrier with the data logger. Always important that the barrier sits behind the bar on these occasions so that it doesn't affect the oven before the thermocouples get there. And just one final item on the hardware before we move on to talk about some of the software features. The radio telemetry system. So this is a radio telemetry link that sends the data from inside the process to be observed on a PC in real time. It's interesting in conveyor processes. I mean, it's novelty. If you've got a processor 20 minutes long to see what's going on inside it, it probably wouldn't be of great benefit. But where we come to, we've got batch or semi-batch processes with large racks, maybe rotating inside the oven, then it's really useful. Because what we can do now is place the entire profiling system on the rotating rack. We can measure the product's top, middle, bottom, and we can have that data in real time to coming out to the PC screen, so that as soon as the cook criteria has been met, you can make the decision to finish the batch, move on to the next one. So it really does help to have that real-time information in optimizing those batch cooking processes. This radio system is a low power transmitter inside the logger. We've got these systems working in brick kilns that are hundreds of meters long. We've got them working in multiple batch cooking ovens, where there's 6 or 7 ovens coming back to one receiver. It's a very powerful way of seeing what's happening inside the process as it happens. So we looked at the data logger, selection of thermocouples, how we protect the data logger, and maybe getting some real-time information. It all comes back to the software. The software is the part where we turn the raw data into some meaningful information that you can base decisions on. We like to think it's easy to use, and we use it daily, so for us it is easy to use. But for infrequent users and novices, everything I cover today can be accomplished using the wizards in the software. They step you through the process, just ensuring that every step is completed before you move on to the next one. With the added advantage that once you're inside the wizard, if you click on the help button, the help will be context sensitive, meaning you will get help on the step you're currently doing. So I do advise infrequent users, use the wizards. Okay, so on the screen image here, you can see a typical capture from a profile run. In this case, we have a time and temperature graph. It's been enhanced. The operator here has created what we call a process file, which includes detail, a photo of where the thermocouples were placed, also some detail about the oven length and the oven zones, and that's overlaid on top of the graph. And those of you who are looking at detail at this slide will see the vertical lines marking the oven zones. And in this case, I would suggest they're not aligned very well, in that the vertical line marking the end of the oven there would probably be where the temperatures start to drop. So I would say there's a slight misalignment on this graph between the oven zones and the trace. And you can see air temperature in the first zone, very different to in the second zone. So that transition is probably, those oven zones just need to be moved a little bit to the right. I talked about rotating racks, and just one example of how the software makes life easier for you. In the process file, you can have a photograph of the rack. You can build that into the software. It gets printed on all the reports. You can drag the thermocouples into position, so it looks really nice. On the rack, you don't really get the detail in terms of depth. So if you've got a thermocouple at the back and another one at the front, that's very difficult to show on a simple photograph. So there is the ability to create these kind of wireframe images that you see on the right-hand side there. And then you can place the thermocouples really precisely onto each level within the racking system, but also front and back and middle. So, you know, do consider that when you're using the system. And it's useful because in a rotating batch oven, you can, again, in the process details, once you've built in that wireframe model, you can enter have the rotation time for the rack. And you can see here when we're analyzing a cooking process, batch cooking process with the rotating racks, you can see down at the bottom here, in addition to the data, I'm getting the number of rotations that have occurred at that stage in the process. So we're looking at this point here in the line. And in fact, on the temperature probe here, you can see a very regular pattern as the rack is rotating within the process. There are some advanced features within the food profiling insight software, the food insight software. And one of these is represented by a little circle or a ball up on the toolbar, and you can see that image called out on the right-hand side of the slide here. Now, this is a feature I want to talk about because it's similar to something that some of you will have seen in other software from Fluke Process Instruments. It looks very much like profile prediction, for example, that we use in the electronics industry. This is a feature that was originally requested by a manufacturer of snacks. And once a first profile has been taken and you've done a numerical analysis, for example, in this case, a lethality calculation or maybe a time over temperature measurement, this allows you to increase or decrease the temperature profile in steps of 1 degree and see the effect that that change has on your calculated results. It's not predicting the changes you need to make to the oven. This is just saying, if you increase the profile temperature by 3 or 4 degrees, this is what will happen to your lethality. It's then up to the food technologist, the process manager, to make the changes on the oven that will achieve that increase in process temperature. So it's helpful. It's not going to tell you what change you need to make on the oven. That's up to the operator, the process manager, to decide. But remember, in all of our software, you can overlay multiple pack files. So if you've done a measurement and saved it, you've then gone through this stage of using the process optimization tool to increase those temperatures, and it's telling you what will happen. You can then do a verification run through the oven and overlay one on top of the other and see whether you actually achieve the results you needed to. It's quite a powerful tool when you're making changes to the oven to overlay those different pack files one on top of the other. Finally, a few slides on lethality calculations. I've mentioned more than once that you can do these within the software, and I think some of the slides up till now have shown images with a lethality calculation on there. The real benefit in doing lethality calculations based on thermal profile information is that you're doing it based on the profile throughout the oven. So you get that contribution to the bug kill for the full process. In the hands of a food technologist, this is a really powerful tool. It can be used to optimize processes while ensuring food safety. All of the results that we get can be printed out. There's actually a specialized food lethality report that comes out of this Insight software. I'll show you an example of that. This slide is showing a screen capture taken from the process details. So this, I mentioned earlier, you have a time and temperature graph. If you overlay a template that includes the oven and recipe settings, it makes all the data more meaningful. One part of the process that can be set up is the lethality calculations. So in here, the food technologist can enter the target bacteria along with the Z values, decimal reductions, and the reference time. And as you can see at the top of the screen there's an add button. You can add as many of these as is necessary for your particular process. The description is a text field. You can type anything you need in there. And the data for this is typically something that the end user has. there's a Save As button, and you can password protect it. It's very important for any food safety calculations that it's the food technologist that's setting up this information, and it's saved on the PC within the Insight software and password protected, so that, you know, unintentional changes cannot be made. The bottom half of that screen shows the alarms. The alarms feature is very useful in that you can set an alarm value for these S0 values, and as soon as the line operator downloads another new pack file into the PC, as long as he selects the correct profile, all of that checking will be done automatically at that point in download. So you get an immediate go, no-go indication for the process. Okay, the technology to set this up for you. You've done a run, you download it. This is what it could look like. On the left-hand side of the screen, you're seeing a time and temperature graph in the top half of the display, and in the bottom half, the analysis tab, we've selected to look at the lethality calculations. And in addition to showing the decimal reductions that have been undertaken, we get a graph that shows that. So we now have a time and temperature graph at the top, and the smaller graph is all around the decimal reductions that have occurred in the bacteria kill. Now, if we look at more detail at the time temperature graph, the difference between that thermocouple that's running a bit low and the thermocouples that are at the correct temperature is about 6 degrees at the oven exit. That's what you would measure if you had a handheld meter at the oven exit and you were probing samples of food. The lower graph shows the difference in decimal reductions, or the bacteria kill that occurred during the process. And now you see the brown trace is right at the bottom. So if we look here, these are the 3 normal thermocouples, if you like. They correspond to these. And if we look at this thermocouple that was on the other side of the conveyor, where there was an issue in this oven, it was running cool, we can see it appears right down here. So a completely different level. So food coming out from that side of the oven, or product on that side of the oven, would not have been as well sterilized as the products on the other side, so shelf life would have been affected. A very clear indication that having the information for the whole profile is substantially better than just measuring at the exit. As I mentioned earlier, reports. So the software does print very comprehensive reports. On the right-hand side is a very familiar time and temperature graph with the process details and pictures of where the thermocouples were placed. On the left, a detailed F0 or food lethality report can be created. So both of these exist as standard within the software. The user can choose exactly which fields they want to report or not to report. And these files can be shared. There's an email function within the software, so you can share the full file with your colleagues, and there's a free viewer that they can download from our website and install on the PC to be able to look at the files in detail. For those people that are on mobile or off-site, we do now have an app available for both Android and iOS operating systems. So available in the stores, the appropriate store. This will enable you, or provide the pack file viewer functionality on a mobile platform. So this will enable the user to look at a Datapaq file that's been shared from within the Insight software. So if you need to share or have an urgent question and your colleague's not in the office, you can at least send them the file and they can check and reply to it on the go. Okay, I think that brings me to the end of this presentation. We skipped through very quickly what is, in fact, a very in-depth subject. So I hope there's something in there that's pricked your imagination, and hopefully there's some questions coming in on some of the points we raised. Thank you for your attention.
Thank you very much, Rob. That was a very good and interesting presentation. Food's a very complicated subject, and yeah, you covered it very well. So we have had a couple of questions come in. First one here is, how long does the thermal barrier last in the frying process?
Okay. Well, the first thing to point out is the thermal duration of a thermal barrier is related to its size. So it's not, there's a specification given for each thermal barrier. Those that are used in frying processes, the thermal duration will be halved compared to its duration in the air. So typically, it's better to come to us with the exact process details, and then we can suggest which barrier is optimum for the process. But yeah, the duration is reduced when used in oil as opposed to air.
And thank you. And can we rewire the thermocouple connectors for the food probes?
Yeah, good question. We, where possible, all of our profiling systems use standard thermocouple connectors, but in this industry, it's really not possible to get a good seal on a standard thermocouple connector. So we use those sealed versions that you saw earlier. The connections in those are crimped and the connectors are sealed, so it's generally not possible. It's not recommended because reworking those connectors will impact on the sealing. So we would recommend they get replaced at that stage rather than reworked.
Very good. Another question here says, can I show 11 shelves in the product 3D map?
Yes, there is a limit on the number of shelves. I mean, 11, you're already up to quite a lot there. Sorry, that wizard will allow you to show anything from 2 to 20 shelves for the rotating racks in that process. So yeah.
Thank you.
11 we're okay.
And there's a temperature, there's a question that's just come in here. Is there an option for a humidity sensor for higher temperatures than 200 degrees C that goes with the food tracker?
At this stage, there isn't. The humidity sensor that you saw with the food system there is based on a capacitive sensing technology, and that is actually limited at 200 degrees at the moment. There are other technologies for measuring humidity within environments. Wet and dry bulb is one of them that they can operate above 200, but they become very difficult to implement on a profiling system that's going through the process. So for the moment, I'm afraid that sensor is limited to 200. We are always on the lookout for new sensor technologies that we could use.
And one more question has just come in here. Why is the humidity important to measure in biscuit baking applications? Well, I'll try and take this one if you want. In baking applications, people tend to be looking for a crunch and a crust, as Rob described on bread. And in biscuit baking, that crunch is often a result of humidity in the atmosphere during that baking process. And to make that repeatable and consistent, customers will always want to measure the humidity levels within that oven and make sure that it's consistent and controlled.
And just on that point, that's typically done on a conveyor process. We've only got one humidity sensor on the data logger, so we would recommend running it both left and right on the ovens, just to ensure that whatever humidity injection system is there is actually uniform across the belt, so you're getting that uniform texture on the product.
Yeah, good point, Rob. And I think that's it.
So if there's no more questions, I will hand back to Leonardo, I think.
Thank you, Rob. Thank you, Stuart, for the very interesting session. there is an opportunity for me to thank you again, all of you, to participate in this webinar. Please check our LinkedIn page in the upcoming weeks to see which are the webinars that we are planning for the future. Thank you very much again to Rob and Stuart.
Yep. Just one point, Leonardo. I will send you that white paper that I mentioned at the front end of this webinar so that you can share it with the people who are on the call.
Of course, I will.
Okay.